Dear students, once again I welcome you all to our YouTube channel Gsquare Maths. So, I am so tired today. I am not able to continue today because I continuously worked for so many hours. If a person is saying this type of statement, what we can understand? The person is worked for continuously years together or hours together or days together. That means he has worked without any break. My dear children, we are going to discuss the same thing it is. A function when it is continuously going, what does it mean? We studied about the function. We studied already the limit. We know that when this limit exists for a particular function for the particular point. And suppose for example, y is equal to x plus 1. It is an equation and this has no break at all. If there is a break, what is the limit value of the function we already studied? When for a given function at a given point, how a function is defined, how a function limit exists. We already studied left hand limit, right hand limit and also the functional value. Left hand limit value is different, right hand limit value is different, functional value is different, which we already studied elaborately in the previous chapter. When left hand limit value is equal to right hand limit, we used to tell the limit exists at the particular point. The limit value is nothing but the LHL value and right hand value if it is equal. When we are saying that functional value if it is also equal, in calculus, we are studying about the functions. Various types of functions we already studied. Linear function we studied, quadratic function we studied, signum function we studied, greater integer function we studied, lesser integer function we studied, victory function we studied, modulus function we studied, and step function we studied. So many types of functions are there in this because the calculus deals about the function only. Calculus deals about change in the function, especially if the function is discontinuous at the particular given point. Now let us see. For example, let us take the signum function. Signum function is nothing but a function fx is defined like this: mod x by x for all x is not equal to 0 and equal to 0 if x is equal to 0. This we already studied. Then what is the limit value of the given function at the point x equal to 0? This function, if you graph it like this, it will come y is equal to minus 1, y is equal to 1 and this is the value. This is the positive x-axis, negative x-axis, positive y-axis and negative y-axis. Mod x by x means, I can elaborate like this only, minus x by x if x is negative, plus x by x if x is positive and equal to 0 if x is equal to 0. That means minus 1 if x is negative, plus 1 if x is positive and equal to 0 if x is equal to 0. That's what I have drawn the graph. If x is negative, it is minus 1, y is equal to minus 1. If x is positive, y is equal to 1 and at x equal to 0, the function is defined like this. Now my dear children, for any function has its own graph. When I am drawing the graph for this particular function, I am not able to draw the curve continuously because I have to see to complete this function. First I have to draw this line, then I have to take the pen out, I have to draw the line like this, then I have to put a dot like this. The functional graph cannot be completed without lifting the pen from the paper. Another example, step function. 1, this, this we already studied. The greater integer function we used to call it as. Greater integer function or lesser integer function, lower integer functions. So this looks like a step. Therefore, this function is also called step function. It is also called a post office function. That's another story of this function. So this complete entire graph of this function, we cannot draw the graph without lifting the pen. See, this is the part of a graph. I have to lift my pen, then I have to complete this. I have to lift my pen, I have to complete this. I have to lift my pen, I have to complete this. So the graph of the given particular function cannot be completed without lifting my pen. So in other words, I can say that we cannot draw the graph of the function without lifting my pen. There is no continuity of the graph. Another example. What is this? Function fx is defined like this. It's equal to 1 for all x is not equal to 0. Is equal to 4 if x is equal to 0. Let me read this function, how it is. The function is defined when for all real numbers, that is, function is defined as 1. So y is equal to 1 is this line. Y is equal to 1 is a line parallel to the x-axis. When x is equal to 0, the function value is defined as 4. This is 1, this is 2, this is 3, and this is 4 somewhere. So when x is equal to 0, the function value is defined as 4. When x is equal to any other real values, x is defined as 1. What we can interfere in this? If you want to complete this graph of this, I have to draw the straight line from here, straight line, straight line, straight line, straight line. But there is a hole. This is not included in this. When x is equal to 4, the function value is equal to 4. So I have to lift my pen, put a dot here and lift the pen, again draw the line, continuous. So there is a break, there is a hole. I can say that the function is discontinuous. So continuous, very roughly speaking, I can define like this: the respective graph of the given function, if it can be drawn without lifting the pen on a plain paper, then I can say it is a continuous function. Otherwise it is discontinuous. But for a scientist, for a scientist and mathematicians, all the time it is not possible to draw the graph of the respective functions. So they need a mathematical way to find out whether the function is continuous at a given point or not. So how will you define the function? Is continuous. When fx is said to be continuous, if and only if. Note the sign what I am using, that if and only. This means if and only if. What is this? I will come back. A function fx is continuous if and only if. 5 conditions. First condition, left hand limit should exist. In the previous chapter we already seen that left hand limit how to find out, right hand limit how to find out. Left hand limit may exist, right hand limit may exist, may or may not exist. 2. Right hand limit should exist. Third one, LHL should be equal to RHL. For a given function, at a given point, left hand limit may exist, Right hand limit may exist. It may be equal or may not be equal. So the left hand limit should be equal to right hand limit. Fourth one, functional value should be defined at a particular point. Functional value at the given point x equal to a should be defined. Fifth is very important. LHL should be equal to RHL should be equal to functional value. If this is true, then we can say that the function is continuous at the point A. So let me define. Let fx a given point, given function, and let x is equal to a is a given point. Let fx a given function and let x is equal to a is a given point. At that particular point, I want to find out whether the function is continuous or not. Then we define like this: limit as x tends to a of fx should be equal to f of a. This is a simple definition of continuity. This definition gives you the 5 steps. Limit x tends to a fx. When it will exist, left hand limit should exist, right hand limit should exist, both should be equal, but it need not be equal. If it is equal, then limit exists. The limit exists doesn't mean that function value is same. Limit value is different, function value is different. In the limit we already studied. Limit value is different, need not be equal to function value, may be equal to function value, or need not be equal to function value also. Here what I am saying that if the limit value is equal to the functional value, then the function is continuous. So here in the graph just now what we have seen that fx we define like this: 1 if for all x is equal to 4 if x is equal to 0. So this is a graph of this. The left hand limit at the point 0, limit x tends to 0 minus, that means this side. This is a point 0, x equal to 0. Left side means this. The train is approaching from the left side. The train is approaching from the right side. That's what we had seen in the first chapter. So x tends to 0 minus means from this side. The function value is equal to f of 1. And limit x tends to 0 plus of the function is also 1. Limit, left hand limit exists, right hand limit exists, both are equal. So you should not conclude that it is continuous at the point x equal to a. One more condition it should satisfy. What is that? We have to find out the functional value. Whether the function value is defined or not. In this case, function value is defined. At x equal to 0, the function value is defined as 4. Limit value exists, LHL exists, right hand RHL exists, both are equal also, but the function value is not equal to the limit value, and hence the function is discontinuous at the point x equal to 0. That is what we are drawing the line, continuous line, a linear equation, continuous line, but to complete this I have to lift my pen and I have to put a dot. So my dear children, these are the 5 conditions it should satisfy. Now I coming to why I put if and only if. It's a mathematical concept. Very, very important concept. Very often you will come across this type of word. What is the meaning of if and only if? It's a mathematical statement about a function we are discussing about. A function is said to be continuous if and only if. That means if function is continuous, this is true. Conversely, if this is true, function is continuous. If that is the case, in Pythagoras theorem we know that in a right angle triangle, the square of the hypotenuse is equal to sum of the square of other 2 sides. And conversely also, in a triangle, if the square of one side is equal to sum of the square of other 2 sides, then we are telling that it's a right angle triangle. So, what we can understand, if it is a right angle triangle, this is true. One hypotenuse square is equal to sum of the square of other 2 sides. In a triangle, if the square of one side is equal to sum of the square of other two sides, then we can conclude that that triangle is a right angle triangle. So converse also true. In that case, we could use if and only if. So if and only if is a mathematical important concept. Whenever in a mathematical statement, the given implies something and that implies given. In that case, we can use if and only if. So, very simple. Continuity of a function at a point x we can define like this. If the limit exists and if the limit is defined, limit need not be defined for any function at a given point. If the limit value is equal to the functional value, then we can say that the function is continuous at the point this. Let us take a small example. Fx is equal to mod x. Mod x, we know that it is a vector function. It is minus x for all x is negative and positive x for all x is greater than or equal to 0. If you graph like this, x is greater than 0. This is x equal to 0. This is the positive x axis. This is a negative x axis. Positive y axis. Negative y axis. It is plus x for all x is positive. X is positive. Y is equal to x. Y is equal to x. Sorry. This is y is equal to x. If x is negative, this is a line, and if x is this is a line. We used to call it a vector function. V function is a modulus function. Modulus function is y is equal to modulus function. Mod x we used to call it as. So here let us find out what is the left hand limit. Limit x tends to 0 minus. 0 minus, that is this side of, negative side of x axis. The function value is this. So that is minus x. Minus 0. That is equal to 0. The right hand limit. In the right hand limit, the function is defined as y is equal to x. In the left hand side, it is defined as y is equal to minus x. The right side, the function is defined as y is equal to x. So limit x tends to 0 plus x is equal to positive 0, that is 0. So LHL exists, RHL exists, LHL is equal to RHL. So LHL is equal to RHL is equal to 0. Now what about the functional value f of 0? F of 0 is also defined, it is 0. LHL defined, RHL defined, they are equal, function value is defined, function value is also equal to this, and hence the function is continuous at x equal to 0. So dear children, let us see one more example. I hope this example is very clear. Modulus function is a continuous function. Continuous is a linear, this is also linear, all linears are continuous, this is also continuous, at the point 0 is also continuous, and hence the function itself is continuous. Let's take one more function. A function is defined like this. On a real number domain, is divided into two categories. X not equal to 3 and x equal to 3. This is x equal to 3. This side and that side, the function is defined like this. Very simple, diagrammatically just representing this is not the graph of this function. At this point, the function is defined as 7. At the left side of 3, function is this. At the right side of this, function is this. And at the point x equal to 3, the function is defined as 7. Now the question is, discuss the continuity at the point x equal to 3. To discuss the continuity of the given function at a given point, what we have to do that, we have to find out the left hand limit, we have to find out the right hand limit, and both should be equal, function value should be defined. If LHL is equal to RHL is equal to function value, then we can say that the function is continuous. Here, as the function is defined alike on either side of 3, left side also the same function, right side also the same function. And hence, instead of left hand limit and right hand limit, we can find out the limit value. So let us find out the limit value. Limit x tends to 3 of fx. Limit x tends to 3 of x square minus 9 by x minus 3. That is equal to limit x tends to 3. A square minus b square can be written as x minus 3 into x plus 3 by x minus 3. My dear, this concept, x tends to 3, x tends to a, we already defined. The train is not in the station, the train is approaching the station. The train is x, x is approaching the point 3, it has not taken the value 3. Either it may be left side or it may be right side. Whatever may be the side is, the value of x is not equal to 3 at all. When x is not equal to 3 at all, this is a non-zero number, this is also a non-zero number. A non-zero can be cancelled. You have to be very careful. In the numerator, denominator, if you want to cancel 0, you have to be little careful, non-zero numbers. If that is the case, 5 into 0 by 0, 0, 0 and cancelling equal to 5. No. Basic concept. Mistake. A non-zero number can be cancelled. This is a non-zero, this is a non-zero, and cancelling this. And limit value find out, 3 plus 3, that is equal to 6. So limit value is equal to 6 here. When I say the limit value, as the function defined alike on either side, left hand limit, right hand limit, is all are equal and is equal to function value. Function value is defined as now how? At the point x equal to 3, the function is defined as 7. The limit value is coming as 6. The function value not equal to f of 3. Why not equal to 3? For f of function at the point x equal to 3, the function is defined, the function value is defined as 7. The limit value is coming as 6 and hence they are not equal. So limit value is not equal to function value and hence the function is discontinuous. So like that, the function can be defined in any way. We know how to evaluate the limit values. Very simple concept of continuity. If limit value of the given function at the point should be equal to function value. That's all. Now when a function is said to be discontinuous, if any one of the 5 points, what I discussed, left hand limit, right hand limit, both should be equal, function value should be defined, all the 5 should be equal. If any one of this fails, then we can say that function is discontinuous. There is a hole in the graph. There is a gap in the graph. Y is equal to 3. Y is equal to x plus 3. So the line is like this. At the point x equal to 2, suppose the function is not defined here. Then we have to find out. I can draw the line, it's a linear equation and hence it's a straight line. That's it also straight line. At the point x equal to 2, the function is not defined. There is a gap, there is a hole on the graph. And then I have to lift the pen like this, continue. The function is discontinuous. Left hand limit exists. Left hand limit is equal to this. Right hand limit also exists. From this side also it exists. And the value may be 5. This may be 5. And this also 5. It's coming like this. You can just get the value. And the function value of 2 not defined. Left hand limit is defined, right hand limit defined, both are equal, functional value is not defined, and hence the function is discontinuous to the point. How to remove the discontinuity? Another question in this continuity, how to remove the discontinuity? The same example, let me explain again. F of x is equal to x square minus 9 by, for all x is equal to 3, not equal to 3, and if x is equal to 3, it is k. Find the value of k so that the function is continuous. The starting of the definition itself, I told you that the case is if and only if. If the function is continuous, all the 5 points are true. Now here it is given the function is continuous. Therefore, this given all 5 points are true. So what is given here? You are asked to find out for what value of k the function is continuous. That's a question mark we got to find out. It is given the function is continuous. Find the value of k. Another type of question they used to ask. So what we got to do that as the given function is continuous, LHL is equal to RHL is equal to f of a. In this case, limit value x tends to 3. Why I am taking the both together limit value? Because on either side of 3 the function is same. Limit value of fx is equal to f of 3. So let us calculate limit x tends to 3, x square minus 9 by x minus 3 is equal to f of 3 is k given. You are asked to find the value of k only. And this limit x tends to 3, x plus 3 into x minus 3 by x minus 3 is equal to k. We can cancel this. Substitute the value x equal to 3 in this. 6 is equal to k. So, if k is equal to 6, the function will be continuous. If k is taking any other value, the function will be discontinuous. So, to remove the discontinuity, the question may be like this: remove the discontinuity. Or find the value of k so that the function is continuous. Remove the discontinuity means here in the graph. Graph is like this. At the point x equal to 3. And the function value is given, here it is 7. Earlier case. Here it is 6. So if that point is coming closer to the same point is given here, then without lifting my pen or pencil, I can draw the graph. The function is continuous. My dear children, this is a very simple, and after this we are going to have what is the algebra of a function. Same algebra of limit we studied, same type of algebra of continuous function we are going to study. Let fx and gx are two continuous functions. Fx and gx are two continuous functions. That means without lifting my pen or pencil, I can draw the graph of the given function. That's the meaning of continuity what we have studied. So this also continuous, this also continuous. First, f of x plus g of x. Algebra of functions, continuity we are studying. If two functions are given, both the functions are continuous, sum of the function is also continuous. Suppose, for example, this equal to fx is equal to x square. And gx is also sin x, for example. X square is a continuous function, is a parabola, quadratic function. Quadratic function is a parabola, this is nothing but this. Y is equal to x square. So this is the parabola I can draw without lifting my pen at all. So it's a parabola, it is a continuous function. Sine graph, that also we studied already. It goes like this. So this also continuous. Without lifting my pen I can complete the graph. So this also continuous, this also continuous. Now listen. This also continuous, this also, both are continuous. Sum of the two functions is also continuous. That means, that is, x square plus sin x is also continuous. So first rule I can say that if fx and gx are two continuous functions, then the sum of the continuous functions are continuous. The difference of the two continuous functions are continuous. Second one, f of x minus g of x is also continuous. Is continuous. Sum of the two continuous function is continuous. Difference of the two continuous function is continuous. Third one, the product of two continuous function is also continuous. Then fourth one, the quotient is also continuous provided g of x not equal to 0. Then fifth one, if fx is a given, already is a continuous function given. So any multiple, alpha is a number, any number. Alpha in this fx is also continuous. So my dear children, sum, difference, product and quotient of two continuous functions are always continuous. And the scalar multiple of the continuous functions is again continuous. And this, as it is, we are going to apply in doing the sum problems. And sixth one, all polynomials are continuous. All polynomial functions are continuous. Suppose y is equal to x square plus 3x plus 2, for example, is a quadratic function. So this being a polynomial, it is continuous. So continuous functions are continuous. Another is y is equal to x cube. It is also a polynomial. So and hence it is a continuous. So therefore, y dash you can keep it as y plus y dash. That is x square plus 3x plus 2 plus x cube. It will also be continuous. If you add this 2, it is nothing but x cube plus x square plus 3x plus 2, which is again a polynomial. All polynomials are continuous. So let us do some problems. You can see one more thing also. If f and g are two functions, the composite functions of that also are continuous. F and g are two continuous functions. Then f circle g of fx is also continuous. I am not explaining what is the composite function, which we already studied in the previous classes. So composite functions of a continuous functions are continuous. So let us take some example. A function is defined. A function is defined like this for all x not equal to minus 1. So the number domain, a real number domain, minus plus infinite, minus infinite. So there is a separation of the number line at the point x equal to minus 1. This side and this side, the function is defined like this. Both sides the function is defined like this. Now we have to define at the point x equal to 1, how we are going to define and so that the function is continuous. And this is a polynomial, this is a polynomial, polynomials are continuous, so continuous by continuous, third formula of properties says that if f and g are two functions, then the quotient is also continuous. So these are continuous functions. So this both the sides are continuous. Whether it is a continuous functions or not, throughout the real number, even at one point the function there is a break, it is not continuous. Dear children, is very careful. Even if one point there is a break, the function is not continuous. To be continuous, a function should be continuous in each and every point in its domain. Here, this side is continuous, this side is also continuous. This side the polynomial, this is a polynomial by polynomial, rational function. So the question comes here, how you are going to define to make the function continuous. So what we got to do that, we got to find out the limit value. So let the limit x tends to minus 1 of fx. That can be factorized as x minus 3 into x plus 1, yes, by x plus 1. And this 2 can be cancelled, and that is equal to minus 4. X substitute x equal to minus 1, minus 3, minus 4. So, this side is continuous, this side also continuous. That the entire function in the domain, real number domain, to be continuous at the point x equal to minus 1, the function should be defined as minus 4. And then it is continuous. Dear children, so far what we discussed about the continuity of a given function at a given point. At a given point, a function to be continuous, there are 5 conditions. Left hand limit should exist, right hand limit should exist, both should be equal, functional value should be defined, and limit value should be equal to functional value. That is, LHL should be equal to RHL should be equal to f of a. Then we can say that the function is defined at the point a and it is continuous at the point x equal to a. Now so far the examples what you have seen that we discussed the continuity of a given function at a given particular point only. Now what's the next big chapter? What is the continuity of a given function in an interval? So far we discussed about the continuity of a function at a given point only it is. X is a point, x equal to a is a given point. Now a closed interval is given or it may be an open interval also. What's the difference between these two? This is x is equal to a and x is equal to b. Open interval, this is not included. Now my dear children, you are asked to discuss the continuity of the given function at each and every point. How many points are there in the interval? Infinitely many. In between any two rational numbers, how many rational numbers are there? Infinitely many rational numbers. Even between 1 by 4 and 1 by 2, infinitely many. That's the beauty of mathematics. In between any two rational numbers, infinitely many rational numbers are there. So, A, B is a closed interval. It's a closed interval, it is an open interval. Open interval, closed interval, what is the difference? The endpoints are not included here. So, here also infinitely many points, infinite many number of points are there. Here also infinitely many number of points are there. To discuss the continuity of a given function in an interval, we can define a function is said to be continuous in a closed interval or open interval if it is continuous in each and every point in the interval. So the big question comes, how will you check? We have calculated this problem to discuss the continuity of a given function at a given particular point. We calculated everything. Now, infinitely many points, you go to this point, this point, this point, each and every point we have to discuss the continuity, which is practically not possible. But simply we can define a function fx is said to be continuous in a closed interval or open interval if and only if, again using if and only if, it is continuous at each and every point in that interval. For that, a standard theorems we can apply. That's the only possibility, there is no other way to do that. How much time you take that, each and every point we cannot check at all. Why? Because the beauty is infinitely many, uncountable number of points are there. Okay, so now for that we are all polynomials are continuous. These are the theorem, we can apply that straight away to discuss the function, the continuity of a given function in a given interval. Polynomials are continuous. Trigonometrical functions are continuous, especially sine and cos. And tan is continuous in particular intervals. See the tan graph, if you see that, you already studied that, just I'm explaining this. Because x is equal to pi by 2 and x is equal to minus pi by 2. And another point, it will come like this. X is equal to 3 pi by 2. This is a pi. So like the infinitely many curves will go like this. So my dear children, from open interval minus pi by 2 to pi by 2 to the function tan graph is continuous. Similarly, trigonometric functions are continuous in some particular interval, whereas sine and cos is continuous throughout. For any real number domain, it is continuous. So exponential functions are continuous in an interval. Logarithmic functions are continuous in a particular interval, because e power x and this is log function, y is equal to log x, and exponential function is this, y is equal to e power x. This is continuous. Without taking the pen I can draw the graph. Without taking the pen I can finish the log graph. But it is continuous at domain only. Negative values, log is not defined. For negative values, this also, for any values of x, exponential is always positive, e power x. So logarithmic is continuous from minus infinite to plus infinite. And the values, similarly e power x and log x also. So my dear function, these are the properties we have to apply to check the function is continuous at this point or not. See, for example, fx is equal to x square plus 3. You are asked to find out whether it is. Discuss the continuity of the polynomial x square plus 3. Or x power 5, 3x cube plus 7 is a polynomial. We can simply say that as polynomials are continuous in real number, the polynomial fx is being a polynomial is continuous in this closed interval also, and hence this function is continuous. So like that, a function we can discuss the continuity of a given function in a closed or open interval also. So my dear children, with this we will close down today. Thank you very much for watching today's video. If you are having any doubts or any problem you are having regarding the continuity of a function at a given at particular point or in a closed or open interval, you can post that in this. We will come back to you. Thank you for watching today.